Thank you, ladies and gentlemen. I just want to give you a 20-minute overview on what is this technology, OPC Unified Architecture. This is UA4, and what is the adaptation, what is the technology. And give you a very short overview. There's a 1-minute 30 video also, which you also find on the web, and I try to play it right now.
What is OPC? OPC UA is an open standard that specifies information exchange for industrial communication, particularly on devices within machines, between machines, and from machines to systems in a convergence of IT and OT. It can be used with any software platform, Windows, Linux, Mac, Android, well, you get the picture. And this makes OPC UA scalable. From minimal embedded controllers to massive cloud infrastructures, even mobile devices. OPC UA is equally suited in a closed network or utilized via the internet. Don't worry though, security is baked into the protocol for access control, authentication, and encryption. Because of its flexibility, OPC UA has been widely adopted in industries like automotive, food and beverage, oil and gas, energy and utilities, packaging, building automation, and so on. So, as manufacturing moves into the industrial Internet of Things Industry 4.0 realm, OPC UA is already poised to fulfill requirements.
Okay, so as a summary, it's really what is the most important topic if we want to push data from whatever device or sensor up to anywhere. Top number one is security and reliability, of course. And then I was a little bit nervous when the politicians in the morning said, yes, but the Germans can't think about a German standard. Of course not. I mean, we are an international export leading company, and of course the Germans need international standards. Somebody who is doing on local standards will lose, of course. So the organization, the OPC organization, which I'm representing, is an international organization all around the globe. Today, more than 400 members, half of them, yes, from Europe, because in this area, Europe is leading. The specification, what the organization is doing, is an international IEC standard. This is super important. It is not bound to a specific company. It scales from smallest sensor to server to cloud, and again, it's independent from any vendor, from any operating system platform, from any language, and it's independent from any domain. We are not talking about wind turbines or a sensor or a smart meter. It's open to be able to be adapted in any kind of domain. And we are not talking about a protocol. OPC UA is not a protocol. Then it would be Unified Protocol. The name is Unified Architecture, which means the underlying levels have the real physical protocol, and this is today TCP and HTTP. It is becoming UDP till end of this year, and it's becoming begin next year, even AMQP. And if I see outside, well, MQTT or other protocols are popular, there's no blocking mechanism to also include that. As mentioned before, OPC is an international organization, and I already mentioned 50% are from Europe. OPC UA is very popular inside the industrial automation market. That's where everybody knows OPC. Maybe you have in your mind OPC is something Microsoft-related, COM-DCOM model, and that stupid old-fashioned technology. Yes, that was true. When I was young 20 years ago, this was exactly OPC. Now I'm older, and OPC Unified Architecture is platform, language, operating system independent. And that's why it's growing into other domains. The technology itself is, because it has built-in security, interoperability mechanism, it provides interoperability because everything you do, exchanging information, exchanging the meaning of information, will definitely be on 37 operations. And at the end, the OPC Unified Architecture is adapted because of the modeling mechanism. When I walk here around about this trade show, everybody is pushing data. Hey, my modem, hey, my gateway is pushing data from A to B. Well, yes, okay, but this is not enough. This is not enough for Industry 4.0. This is fine for IoT, but I think we can do better. And for better, we need the meaning of data, the description of data. And the description has also be machine readable. And that's why a lot of other organizations make modeling hierarchical. What is my service doing? What is my device doing? So let's jump a little bit inside this. The specification has been released in 2006 to 8, and the first products have been available to 2008. And so this is just a listing of everything. OPC UA is announced as open source. The specifications have been adapted and are available online and public to everybody. And right now my team is working on all the header and the legal stuff. And within the next 1-2 months, we will open the C# stack first, then the Java, and then the C++. I want to compare quickly, not fair, a little bit black-white, what is the difference between IoT and Industry 4.0. There's a sample on how you just make a gateway in front of all elevators and then collect all the data from elevators into Microsoft Azure, and then you have new business models and analyze predictive maintenance, what is the state of an elevator. Great. I understood this story, fantastic. Yes, it's a business. What is the technology behind? Microsoft and a lot of you, and a lot of your exhibition companies say, somehow we have to collect the data, don't care how. We have thousands of drivers, but we need all the data in the cloud because the cloud is scaling. And of course, Microsoft and others promise new business models on doing analytics on this data. Okay, we got this story. What are these companies doing? These IT companies, they provide a driver, an agent, not only for the Microsoft platform, also for all other kind of operating systems, because they want to have the data. So Microsoft is providing all these data, all these agents to different operating systems, to different controllers. It has built-in security, yes, but it's only transport. You always have to know what are the 10 bytes about coming into the cloud. And of course, this is not Microsoft, it's same with IBM, same with Oracle. But the big question is, do we have interoperability then? No. Does the machine builders like it, or the sensor device makers? No. Because they always have to implement this and that protocol to push data up into a specific cloud. This is not a solution for interoperability. Compared to Industry 4.0, which is more focused on the factory floor, how can machines talk to each other? How can you optimize data flow inside? Machines have to talk to each other. So think about these controllers from different companies, from Rockwell, from Siemens, from Beckhoff, from Phoenix, and so on, that these are different machines. This is a packaging machine, this is a transport, this is a robot. And they have to talk to each other. So you mean we need horizontal communication, we need modeling, we need the meaning of the machine. And yes, cloud and IT is also there, of course, yes. But it's not cloud-centric. The Industry 4.0 recommendation have been published at this Hanover trade show, and inside this paper, Umsetzungsstrategie, hopefully it's available also in English now, it's listing OPC UA as the one and only recommendation for communication. Of course, OPC UA today is not hard real-time. You cannot run a robot with it. It's not eliminating field bus systems. Yes, you still have Profinet and CAN and EtherCAT and Zercos and whatever. But up from that sensor, non-hard real-time data, up to whatever layer is recommended, please make use of OPC UA. And now the question is why? Well, because if you look to a device, could be a sensor, could be a machine. If you look from the outside world to that machine, you need exactly services from that machine. But to access the services, you want to have standardized access. And this access should be secured and, of course, interoperable. And secured means, and this is why machine builders and other device manufacturers love this OPC UA, because they can protect the data and can specifically say for each value, for each tree, for each information, for each web service method, who is able to see, who is able to access, and to call data or to write data. And this makes it interesting because then the machine builder can say, I am the owner of the data, and if I give the data out, I want to be participating in the business model. So security is the outside layer, and so the German BSI information security government part is analyzing OPC UA because of the relevance for the German industry. And they already got all the specifications. This part is done. They didn't find any major stuff. And now they're looking into the source code level, into the reference implementation. And even today, the head of that department has a very fundamental statement below that OPC UA is super secure and the only recommendation what the BSI is doing today. If you want to read that statement in a half a page, it's on page 23 on a brochure, which I have here in German and English, so you can take that brochure with you. Okay. So we have security, we can offer data, and that's why other organizations from different markets now do modeling of their information models inside this OPC UA. We not only want to share data, byte, 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 push. This is what I did 20 years ago when I started my job. Today, all these organizations recognize the power of standardization and of modeling. Now PLC controllers can talk directly to each other because everything which is IEC 1131 is standardized into OPC UA namespace. But devices can also talk on their own, push data somewhere. From the controller into cloud is realizable. You can order it. The RFID companies in the association AIM standardized every 1D, 2D, 3 and barcode scanners to tell the outside world, I'm an RFID reader. So if you go to the RFID reader from Harting or from Siemens to the outside world, they act identical with the same interface, the same for protocol, but also for the modeling of the data. And now you will say, hey, if everything is identical, I'm exchangeable. So that's not a good business model. That's not true. Because every reader has some specific functionality which he can offer additional in a side way. So maybe Harting or Siemens has some specialized functionalities which they also can offer. But the standards, for the standard you have standardized access. And this makes engineering extremely simple because the outside access from the controllers, from the PLC controller or the HMI is semantic identical, and this makes engineering so much more efficient. I just thought, hey, might be interesting? Oil and gas platforms are not cable bound, so they talk about, I don't know, some satellites or whatever. Also, the whole oil and gas industry decided to make every modeling of a oil platform and undersea drilling based on OPC UA. And these oil and gas industry pushed Microsoft to put OPC UA into the cloud. It's not because I'm talking and presenting standards. It's, of course, industry and business behind. So give you some ideas. This is, from my knowledge, the smallest OPC UA server in a commercial way. There are smaller versions with 10 kilobyte footprint, but this is the smallest one which I figured out as a commercial one. It's a smart meter in atomic plants in France for reading energy data. Just a picture, it could be gateways, field devices, of course PLC controllers, operator panels. It goes up to consumer level. Everything is where you can integrate OPC UA as a client or server, or both. Intelligent devices, of course, have both. The existing world, well, I have a factory. What can I do there? I can't renew everything. It's easy to start on a green field, yes. Well, take existing gateways, connect to existing Siemens F5, F7, S7 devices or Rockwell devices, and you are automatically connected. This Hannover trade show, also Microsoft published and made a live demo at the Hannover trade show that they had OPC UA in their Azure cloud. and KUKA implemented OPC UA into their robot. So data from the robot could automatically connect it to the cloud in a simple, super secured, but standardized way. And of course, if you go with a mobile cell phone or with a tablet through your factory floor, you can look to a machine, and there's an M2M OPC UA connection, which gives you also the meaning of the data. And so you are connected, and you have augmented reality. What is the status of that machine? What is the problem? What is the machine producing? So there are a lot of more products. I can't dive into all the details, but OPC UA is not only between controller and SCADA and supervisory level. It goes down into sensor, it goes up into cloud. That's my message here. And as you see, all kind of big PLC vendors have solutions ready to buy. Just 2 success stories. You can download them from the OPC Foundation website. And I thought, let's talk a little bit on the left one, because it has M2M inside. Well, and I know that your definition of M2M is always when a SIM card is inside, right? Which is not my definition, but your folks did really good marketing on that, so congrats on that. I'm coming from the industrial automation world, and M2M really says machine-to-machine communication. And sorry, but I don't care on the physical layer. Could be SIM card, I'm fine, could be cable, could be whatever. This is about water, wastewater, freshwater management. They have more than 600 devices, far distributed in 1,400 square meters. And every device, every pump, every water basement has its own controller, its own device, but and they are talking to each other. But what he does is he modeled data. I'm a pump, I'm a water plant, and so now pumps can talk to on its own to each other. Hey, a farmer did something on my field, water quality goes down, pump 2, please take over. So from supervisory level, everybody has full control every time, but now you have a network of intelligent devices talking on an international standard. And inside this standard is a lot of stuff inside, which normally he has bought before on its own. Like if you disconnect the physical layer, data are buffered. If you reconnect, data will exchange each other, and so on. All this is baking into the protocol itself. Summary. There is a brochure in German and English. I just have 25, so if you don't get one, please let just your business card there, I will send you one. This is really about the adoption, who is behind all kind of international companies, explaining the technologies, giving testimonials, but also reporting about success stories. And, well, this is just a screenshot out of the brochure, skipping that. Well, and that was exactly my overview of the presentation. And because we have 2 minutes, I think we have time for 1-2 questions, right? Thank you, first of all.